Here at Hake Yachts, we use at least a half a dozen different types of fiberglass components in order to make the fiberglass part as a whole. This is one of them. This is called the Vinicel. It's a PVC foam. It's closed cell, impervious to water. And we use it in areas of the boat where we require structure, but we don't want a lot of weight. And weight is everything, of course, in a sailboat. It controls speed and maneuverability. This particular PVC foam we use on flat surfaces, including the deck, seats, and the deck floor. This is another component we use in fiberglass construction. We use it in our hulls. It's called core mat. It's a 4mm core mat, and it's a composite of microballoons, microscopic microballoons, and glass fiber. And when this is wet out with resin, unlike core, which is fairly soft, I can put my fingernail in this core here, but when this hardens, it's very hard, just like a fiberglass laminate. But it's much lighter, and it creates a compression and a tension surface that give us optimum weight strength characteristics, very high shear strength. Everybody's heard of carbon fiber. We utilize this in certain places of our boats. One, for example, is the rudders. This is unidirectional, running this direction, and it's very high strength, lightweight. This is also unidirectional fiberglass here. You can see if you pan it, close in on this, that the directions are running vertical. The component is running vertical. Here's a strand right here. And we use this in rudders and in many places of the boat. Keel for high strength, low weight. This is also unidirectional, but this is what we call triax. This runs in 3 directions. You can probably see there's one strand that runs this direction. There's a strand in the middle of this that you can't see that runs the opposite direction. We call that 45-45. And then we have a 0-degree strand that runs across the roll here. That's on the back side. This is a very dense fiberglass. You get a lot of glass per weight when we use this. We use this multiple layers of this in the hulls of our boats. This is old fiberglass technology. This is what we call a chop strand mat, and it's little pieces of fiberglass similar to what comes out of a chopper gun. There is a place for this in the boating industry. It acts as a veil so that you don't see on the exterior of the gel coat the pattern of the laminate that is backing the gel coat. This will make your gel coat look smooth if you put this stuff on first. It doesn't do a whole lot for strength. We use it for molds mostly, but we do use it as a veil. This is old technology fiberglass. This is called roving. And if you've seen old boats that have a waffle pattern on the outside of the gel coat, this is probably what they used to do it. Many manufacturers still use a roving type laminate in their layup. We don't. We have it here for molds. We really don't care how much our molds weigh. We just try to build them up with as much thickness as possible, and we'll use this and this intermittently. I'm standing next to our 26-foot hull, which is in a mold. The laminating process is complete. The keel trunk has been laminated into the hull. It thinks that it is part of the hull. It's all done at the same time. There's primary bonds. We're looking at overlaps in the lamination here, and that's the triax I was telling you about. The lighter sections of material are the core mat. We have it both on the bottom of the hull and on the sides of the hull. Over the shear is multiple layers of biaxial and triaxial fiberglass. To build our hulls, we first spray a layer of isophthalic gel coat into the hull, approximately 15 mils thick, about the thickness of a matchbook cover. That's the pigment, or the white color that you'll see on the boat. Behind that, we put a layer of vinyl ester, which prevents osmosis blistering on the gel coat surface itself. On top of that, we put a layer of this chop strand mat, which acts as an excellent veil so that you don't see print through on the outside of the gel coat. Over the top of that, for both a veil and stiffness in the hull, we put a layer of 2mm core mat. This is the product that incorporates microballoons and fiber. On top of that, we put multiple layers of triaxial fiberglass. Around the shear of the hull here, we build up multiple layers of 6-inch biaxial fiberglass. This is the part that the deck is connected to. On our boats, it's a little bit more complicated than most boats in that the glass will come up, make a radius, turn 180 degrees, and go back down again. This accounts for excellent structure in the shear of the boat. Let me just clarify that the first few layers that we put on the boat, being the gel coat, the vinyl ester resin, the 1.5 ounce mat, and the core mat, are there to protect the boat from the environment, osmosis, blistering from water, and UV. The strength that comes with every Seaward comes through multiple layers of triaxial unidirectional fiberglass. And we use that throughout the boat. We overlap it, it's hand laid, and then of course we put several layers on the shear. Again, the trunk, which is built at the same time as the hull, we get chemical bonds between the trunk and the hull, is built of the same structure, unidirectional triaxial fiberglass, multiple layers of it, and many more layers towards the bottom where it attaches to the hull. The block you're looking at here on the stem of the boat, it's a wood block, and we use it to pull the hull out of the mold. But it's the only place that we use wood in the hull. When we put the bow eye itself in, it's a composite block that's installed with multiple layers of fiberglass on the back side of it,